Welcome to Demystifying Math. In this lesson, we're going to be discussing projection. We have two vectors drawn, and what we want to do first is find the magnitude of the two vectors. Remember, the magnitude can be found by using the distance formula. So we have both vectors starting at the origin. They're in component form. So we have the square root of 2 squared plus 4 squared for vector u, which gives us the square root of 20 as its length or magnitude. Then we're going to do the same thing for vector v. We have the square root of 5 squared plus 2 squared, which gives us the square root of 29 as the magnitude of vector v. Next, what we want to do is find the angle between the two vectors. So using our cosine of beta formula, we need to find the dot product of the two vectors and divide by the magnitude of the two vectors multiplied together. So our dot product gives us 2 times 5 plus 4 times 2. Our magnitudes we're plugging in. So we have 18 over the square root of 580 as the angle, cosine of the angle between the two vectors. Using the arc cosine or the inverse cosine function, you get about 41.63 degrees for the angle between the two vectors. Alright, so now what we've done is drawn a line that's perpendicular to vector v, and it goes through the endpoint of vector u. This is called the projection of vector u onto vector v. The projection part is vector w1. You can think about it as the line that's going perpendicular to vector v as a light source coming down from vector u and onto vector v, and w1 being the shadow portion of vector u onto vector v. So what we want to do here is find the coordinates at the endpoint of vector w1, which would give us our component form for vector w1. So we need to find the coordinates of point A. Since there is a right angle at point A, we can use right triangle trig to find the length or the magnitude of vector w1. We have the angle between the two vectors, which is in this case w1 and u we're looking at. So we also have the length of vector u, which is this magnitude. So we can use the cosine of vector beta, of angle beta, which is going to be the adjacent over the hypotenuse, where the adjacent side is vector w1 and the hypotenuse is vector u. We know two parts of that, so we can plug in and solve for vector w1's length. So 20 cosine 41.63 is going to give us the magnitude of vector w1. Now that we found the magnitude of vector w1, which is approximately 3.3, we can use that to help us find its coordinates. Since w1 coincides with vector v, it must be a scalar multiple of vector v. So we know its magnitude. All we have to do is find the unit vector that corresponds to vector v and multiply it by the magnitude of w1. So our unit vector for vector v is just its coordinates divided by its magnitude, which we found earlier, square root of 29. And then we're going to multiply that by the length of w1. Remember, the unit vector has a length of 1, so all we have to do is multiply it by the length that we need. And we get around 3.1, 1.2 as the coordinates of the endpoint of w1, which is also the component form of w1. Now that we found w1, we can also find w2, which is the distance between vector u and vector v going perpendicular to vector v. w1's starting point is at the endpoint of u, so it starts at 2, 4, and goes to the endpoint of vector w1, which we found to be 3.1, 1.2. So now all we have to do is take w2 and put it in its component form. So subtracting the x values and the y values, we get that w2, if we had drawn it starting at the origin, would be at 1.1, negative 2.8. So basically we have found the projection of u onto v. Let's try to simplify that a little bit. let's go back through our steps. And you might want to rewind the tape and see, follow it through. But we started off by finding the cosine of the angle between the two vectors, which is our cosine beta formula. Then what we did was multiply that formula by the magnitude of vector u, and that gave us the magnitude of vector w1. And all I've done here is simplify that because the magnitude of vector u's are going to cancel out. Then what we did after that was we multiplied it by the unit vector of vector v. So when we did that, we ended up with the magnitude of vector v squared in our denominator, the dot product in our numerator, and multiplying by vector v. So that gave us the projection of vector u onto v as a simple formula, so we don't have to do quite so much work. So if we can remember the formula, it would be a lot easier in going through the process. So let's just plug into this formula and see that it actually works. So we found our dot product to be 18. The magnitude of vector v was the square root of 29, which we will square. And then we're going to multiply that by vector v. And we get 90 over 29, 36 over 29, which estimates to be 3.1 and 1.2. Now, using the formula, you can still find the vector w2 in the same way that we did. But this gives you a shortcut formula for finding projection. All right, thank you for tuning in.